at ErgoPad. In this video, we're going to go through how to set up the developer environment for the ErgoPad tools so you can try them out. So, just a rough outline, we're going to go through the initial setup, so the required downloads you need to get everything to work. Then we're going to go through how to set up the ErgoPad Quicknode, which is a Ergo node client, but with 700,000 blocks downloaded to speed up the sync time. Then we're going to go through the ErgoPad API repository and how to start that so you can test the smart contracts and interact with the backend, as well as exposing the API. And then lastly, we're going to go through a Ergo Python Appkit example, which uses the Python Appkit library developed by ErgoPad. So now we're going to go through the initial setup for the required downloads you need. So mainly you'll need the VS Code IDE, which you can download. Then we'll need Docker and Docker Compose as well, which is what's used for the Quicknode, as well as starting the backend API. And then to get access to the repositories, you'll need a GitHub account. And to test the Python Appkit library, you also need Python and at least version 3.9 or higher. And optionally, you can download the Python library pyenv virtualenv, and you can read the instructions on how to install that at the link. And it's essentially just a tool to manage different versions of Pythons on your computer. So like I mentioned in the previous slide, we're going to need Docker to run the Quicknode as well as the API. So once you have Docker Desktop installed, you're going to want to go to the settings and just make sure that Docker Compose v2 is selected, because we use that to run the different applications. So now we're going to cover how to get set up with the Quicknode. So the repository, the instructions are at this link, and then I'm going to show you how to start the node, how we're going to update the API key, and then the last step will be wait for syncing. And if you ever need to go check the most recent version of the reference client, you can at the Ergo repository. So this is the ErgoPad Quicknode repository. You're going to want to either fork it or clone it somewhere on your computer. And then I'm just going to go over these steps really quickly. So you're going to want to install 7-zip on your computer in order to extract the blockchain data. And then which you can get the file here. It's a large file, 10 gigabytes. So make sure you have enough space on your computer to download it. And then extract it. And then you're going to want to install the or download the latest release of the client, so you can update the version number to the most recent one, and it'll download the jar to the repository. Then I'm going to go over how to use the Docker Compose and actually start it. So in order to interact with my repository, I could do it through the command line, or just to make it easier, I'll just use VS Code. So I'm going to open the folder where I have my Quicknode repository located. And I'm just going to import it. So for the sake of time, I've already installed the 10 gigabyte file blockchain data, as well as the latest version of the Ergo client. So the next thing we're going to want to do is go to the compose.yaml file, and then just make sure we have the most recent version for the jar file. Just update the number, because this will be the volume for the container. We'll use the jar file as a source of data for the ergo.jar file within the actual container when you're running it. So now we're going to want to recreate our Docker container for the Quicknode. And we do this with docker compose up force recreate. So now the container has restarted, as you can see as well here in the desktop app. And we're going to want to just reload the web page. So now that the page is reloaded, we're going to want to go to switch the URL to panel. So here is where we're going to set the new API key and create a wallet. So now that we have the Quicknode set up, we launch the Swagger UI by going to localhost 9053, and we insert our API key. And now our wallet is connected, if you had already created one. So, and this is where you can see like the information about the wallet, and if you want to send more, like if you want to send a transaction. If this wasn't here, like if you didn't already make one, then you would you could create one, and it would you'd have to generate a mnemonic and just make sure you save it, and then you can log in again into the wallet, and you will get the information. So now all that's left to do is just wait for the node to synchronize to all the way to the current blockchain height, and that could take a while. So now that we have the Quicknode started, the next thing we're going to do is set up the ErgoPad API so you can interact with the backend, as well as testing the Ergo script contracts. So the ErgoPad API repository can be found at the following link. So what we're going to do in this section is show you how the required VS Code extensions that we're going to need, mainly the Ergo script language support for syntax highlighting, and Pylons, which is a language server for Python, if it isn't already installed. Then we're going to go over how to set up the testing for the contracts using the Python Appkit library and PyTest. And then finally, we're going to go over the backend API setup, configuring the environment file, and then running the API interface, similar to the Node interface. So this is the ErgoPad API repository. You're going to want to just clone it or fork it to your computer. And similarly as before, I'm just going to use VS Code, and I'm going to add the folder to my workspace. So now that the ErgoPad API folder is in my workspace, I'm going to quickly create a new terminal for this particular folder. and I'll show you the extensions you need to install. So for the ErgoScript language support, just search ErgoScript and it should pop up. So like I mentioned before, all this extension does currently is just basic syntax highlighting for the common terms, keywords in the ErgoScript language description. And it'll work with any file with the following file of extensions. And the second one is pylines. Usually this should be automatically installed with VS Code. But I know on Mac it wasn't for some reason. And this is important because we're going to be linking pylines to the Python Appkit library so it can recognize the specific types related to Appkit. So the next thing we're going to want to do is install the Python libraries required for this project. So to set this project up, you could have done like a Docker developer environment, but I'm using Python virtualenv, which just lets me manage different Python versions on my computer. So I'm just going to activate that virtual environment. So now whenever I download the specific Python libraries associated to this project, they'll be in the ErgoPad virtual environment and won't conflict with anything else on my computer. And in order to install these specific requirements, we're going to want to go into the app folder of the ErgoPad API repository, and then run git install -r requirements.txt. And this will install all of the Python libraries that you'll need. So this error might happen when you try to install the Python libraries, and it's due to the SigUSD Python library that isn't installing properly. But in order to test the Python Appkit code, you don't need them, so we're just going to comment them out. So go to the requirements.txt file in the app folder, and then just scroll down to where it says SigUSD, and just comment that out. But leave the SigUSD binary because that's needed. And once we comment this out, we're just going to save it and then run the command again to install the libraries. And this time it should all install properly and you shouldn't get any errors. So now the library is installed properly, we didn't get any errors. So now that the Python library is installed, we need to link the pylines to the typings folder of the Python Appkit library. And we're going to need to create a settings.json file within a .vs code folder. And then now I'm going to show you how to set that up. So now back in VS Code, in the repository folder, ErgoPad API, you're going to want to create a VS Code or .vs code folder, and then a settings.json file. And within the curly braces, we're going to want to write these three commands. We're going to set the python.language server to pylines. And then we're going to need to find the directory of the Python Appkit folder. So on your computer it will be different, but in order to find it, we are going to use the command pip show and then the name of the library. So in this case, Ergo Python Appkit. And now the location is what we want. So just copy paste that into the analysis.step path, and this tells you where the library is. So to access the library within this folder, just do add this slash, then the Ergo Python Appkit, and then the typings folder within that library. And then for the extra paths, just do the same thing, but instead of the typings folder, just put the jars folder. So now that we have installed the Python libraries and connected pylons to the typings folder, we're ready to try out running the tests using PyTest. So now we're back in the repository. So what we're going to do now is check the contracts folder. We're just going to pick a contract, so any file that ends with the .es. This one's the NFT log testing. And we see that due to the Ergo script language support extension we downloaded at the beginning, the syntax is highlighted, and this is Ergo script code. And a cool feature is that it only highlights the code that's in braces, since when this code gets used, it gets converted into like a string, and it must be the code must be surrounded by these curly braces, so it just gives a visual signal to the writer they forgot to put a curly brace somewhere. And then the next thing we're going to look at is the test folder, and this is where the off-chain testing happens for the contracts. So this one corresponds to the staking contract. We configure all the inputs and outputs, as well as the necessary values we need to calculate, and then essentially, create the unsigned transaction, and then sign it. But we just don't send it to the blockchain. And then the next thing we're going to check is the env.test file, .env.test, and this is where you can configure certain parameters for the Ergo network, and then any of the databases settings that you need. So right now it's configured for testnet, but you can change it to mainnet. So if your node isn't connected, like if you're not running a node, the tests will still run. Some might not work because they need, unless they need just access to the node for some reason. But this is where you would configure it for the testing. So now we're going to run the test staking file. We replaced the node URL with this public node, the network type to mainnet, and then we put in this API .explorer.com URL for the Explorer URL. So to run the test, all you have to do is use the PyTest command, and then use -s to display any print statements, and then I like to run it in verbose mode, and then the file name if you want to run just a particular file. And as we can see, the test passed. It displayed the tree corresponding to the Ergo script file that it compiled, and there were no errors. So this is the general process you should follow when wanting to write your own Ergo script, and then an equivalent off-chain test using the Python Appkit library. So now that you've set up the Python libraries and know how to run the tests, now we're going to look into the ErgoPad API and running the Docker container for this. So the first step is setting up the environment file, and this is where you put your usernames and passwords for the various databases we use, as well as authentication information. And it's very important to keep this file private from the actual repository itself, so you don't make it part of your Git commit. So the next thing we're going to do is set up the environment file for the ErgoPad API. So in order to do that, I'm going to import the folder where it's contained. And because you don't want to keep the file within the repository itself, you want to keep it outside. So I have it in a folder called ErgoPad config, and I will show you the directory structure. So as you can see, I just follow this folder structure, and this is the environment variable for the project. And this is where you would put your passwords and username for the different databases, access to the Ergo node. These are all just dummy values. And now I'm going to show you how to link this file in the Docker for the project. So now that we've imported the external folder which contains the environment file, we're going to go to the docker compose.yaml file, and we're going to comment out the networks because we don't have those. We don't need those to run the API to test it out, and just uncomment this here. And then we're going to create a new environment file within the app folder, and in this file it's going to reference the external environment file, the location of the external file. So now that we have our environment variable set up, we just need to configure this variable. The API port we set to 8000, and then we link the environment file to the external folder that is not in the GitHub repository project, because we don't want it to be committed or anyone to have access to the values. So now that we have installed the Python libraries and connected pylons to the typings folder, we're ready to try out running the tests using PyTest. So now we've launched the API, the backend API, and we see the Swagger UI, and now you can have access to the different endpoints and see what they do. Some of them are unlocked, some of them are locked. You also need to authorize it with your API key. Yeah, but other than that, this is how to set up the backend API using Docker. So now that you know how to set up the Quicknode as well as running the backend API, we're going to just do a simple example where we're going to write an Ergo script contract and then write the off-chain code using the Python Appkit library, and then we're going to use PyTest to test it and see if it works. So I'm going to show you a contract diagram that corresponds to the Ergo script contract Then I'll show you the actual Ergo script code, and then finally the off-chain Python Appkit code that we'll use to test the contract. So the Python Appkit library itself can be found at the following link in at the repository, as well as the grantor beneficiary pin lock example, which is taken from the Ergo script by example repository. So this is the grantor beneficiary pin lock contract diagram, a high-level overview of what happens. It's very simple. So initially you have the grantor who sends money to the pin lock contract and sets the register of the box R4 as the pin, or the hash of the pin, and the contract states that only the grantor public key or the beneficiary can withdraw the funds, as well as having the correct pin in R4. So as we can see, the beneficiary is able to withdraw the money from the pin lock box, as well as the grantor again if they want. So we're gonna go over how to write the really simple contract for the pin lock box, and it's just a slight modification of the regular pin lock contract. So now we're in VS Code again. I made a simple pin lock example project. It includes the off-chain Python Appkit code, the contract, which I'll go through, and the requirements for the project. So again, I also used my virtual environment. I created a new one called Pinlock, and I installed the Ergo Python Appkit library and PyTest, which are the only two you need for this simple project. So now I'm going to go over the Ergo script contract for the grantor beneficiary pinlock contract. So in this script, as you can see, it's very simple. The only two hard-coded constants we have are the grantor public key and the beneficiary public key, and they're the only ones who are able to withdraw from this box. And we see that the contents of this box, which contains this contract, the value will be whatever the beneficiary wants to send to it, as well as R4, so the register, the first register that you can input data into, will contain the hash bytes of the pin that the grantor inputs. So the inputs to the deposit transaction will be the grantor box, which will just be like their wallet box, them sending money to this address, the contract address, and the output will be a pinlock box with the desired register, like the hashed pin inside, register 4. For the withdraw transaction, which is either the beneficiary or the grantor can do, the input will be this pinlock box with the amount that the grantor sent to it, as well as the hash pin value. The output will be the beneficiary wallet or the grantor wallet box with the unhashed pin in register 4. And this contract in this section here will check to see if the bytes of the pin in register 4 of the output box are equal to the value stored in register 4 of itself. And since this will return like a true or false value, you need the sigma prop function, which will take a Boolean value and then output a sigma prop. And so that this condition, as well as either the grantor or the beneficiary signing the transaction, must be satisfied. Both must be satisfied in order for the funds to be withdrawn. So this is the off-chain section. I'm going to go over how to use the Python Appkit library for the simple pin lock example contract. So we import the hashlib library because we need to take the hash of the pin. And then this is the Appkit Python library from ErgoPad. And the GitHub repository explains why you need to call this library imported right underneath the Python one. So since we're creating off-chain code to test the contract, we create a test class. And now I'm going to go over the different sections. So we first start off by creating an Ergo Appkit object. It's the first parameter is the node URL. So if you're running your own node, it would be localhost 9053, but we're using a public node. The network type is mainnet, and then this is the Explorer URL. And so this is analogous to the Ergo client object in the Scala Appkit. Then the next variables we create are the grantor public key and beneficiary public key address objects. Again, this is like exactly the same as the Scala Appkit, where we create an address object using the base 58 address string. We do that for both of them. Then we have our pin, just an integer, and then we have a miner fee. We just define it as 1 million nanoerg because we use this variable more than once. Then we import the ErgoScript contract. So this was the benefit of having a separate file with a .es extension, because we're able to use the ErgoScript language support VS Code extension to get a basic syntax highlighting, and that helps with reading and writing the ErgoScript contract. So we import the file, and now we have access to it, and then we can use this variable when we want to compile the ErgoScript to Ergo tree, because we'll use the Ergo tree throughout the code. So along with getting the script, we then insert the hard-coded variables, the grantor public key and the beneficiary public key from the address object, which we defined before, and then the Ergo tree gets compiled into this variable. So then the only thing that's now missing is to get the hashed pin, the hash of the pin bytes for the output pin lock box. So now we're going to test our ErgoScript contract by creating different transactions. So the two main ones, deposit and withdraw. So we're going to create a test deposit transaction, and the input box will be the grantor input box. So the grantor who wants to send money to the pin lock contract, we give it a test value of 1,000 erg, or the 1,000 times 10 to the 9. There aren't any tokens, and there aren't any registers, so it's like simulating just sending ERG from your wallet to a contract, an address. And then the contract for this box will be the grantor's public key. So this is a really straightforward way to create a test box. And then we do the same thing for the output box, which is the pin lock box. We give it a value of 100 erg, coming from the grantor, so the grantor sends 100 erg. There aren't any tokens. Then for the register value, the first register, R4, we put in the hash of the bytes of the pin, and we take the bytes of the hash and store that in register 4. So we use the ergo value function from the Ergo Appkit library object. And so this is very similar to like ergo value of in the Scala Appkit. And then for the contract, we take the ergo tree from the pinlock ergo script that we compiled. So this variable pinlock extended tree. And that's our output box. And then we try to create an unsigned transaction. The inputs, the grantor input, there's no data inputs. The output, the fee will be the miner fee that we defined. And then we just send any change back to the grantor. And if it's able to create an unsigned transaction, then we want to print the generated the JSON and display it in the console. So the structure is like very simple, and it's very similar to the Scala Appkit. So now we're going to go to the withdraw transaction. So similarly, this time the input will be the pinlock box. So as before, just to keep the example like the same situation, we imagine that this pinlock box now exists on the blockchain. It has 100 erg in it that the grantor sent to it. It has no tokens, sorry. And register 4 contains the hashed bytes of the pin, and the contract is the pinlock contract. So then the output will be the beneficiary who tries to retrieve money from this box, the pinlock box, and it's going to retrieve all of it. So the funds will be with 100 erg minus the miner fee, right? Because the miner fee has to get paid. There's no tokens, and the register of this box must be the bytes of the pin, because the contract will take the hash of the value in register 4 and compare it with the value that's stored in itself, the pinlock box. And then the contract will be the address of the beneficiary, so the public key. And then we try to create an unsigned transaction. The input being the pinlock box, the output the beneficiary, the miner fee. We define it as the miner fee variable, and then any change left will go to the beneficiary, but there shouldn't be any because we withdraw everything from it, from the pinlock box. And then again, we want to print the JSON to see what it looks like. And then if you're actually trying to create a real transaction, you would then want to sign it and then send it to the blockchain. But we just want to test to see if we're able to create a valid unsigned transaction. So now this is the output of the PyTest. So we see the first print statement was the Ergo tree of the pinlock that we generated from the Ergo script and the inputted grantor and beneficiary public key. Then the first object, JSON object we get is the input box of the grantor. we see the value is the same, correct, of 1000 erg. And basically all of the box parameters you would expect are inputted. And then we see the first output is the pin lock box with 100 erg, which came from the 1000 from the input, the pin lock ergo tree, and the hash of the pin lock bytes, the pin bytes. And then for the withdraw transaction, we have the input being the pin log box with the register value, the hash, and then the output, the first output being the beneficiary, which contains the 100 erg minus the miner fee, the ergo tree of the beneficiary public key, and then in R4, the bytes of the pin, but not hashed. So our two tests passed, and everything works as we intended. So now this transaction could be signed by either the beneficiary in the withdraw case, and by the grantor in the deposit case. So that's it for the ErgoPad development environment setup. You can find us at our website, ErgoPad.io, as well as joining our Discord and Telegram channels. Hopefully you found this tutorial helpful, and thanks for watching.